to a box, which is annoying. I don't know why. But just go with it. So all of these boxes, really just, you can ignore them. Okay? So you have a triangle. Okay, we're going to find the sine and the secant. Oh, wait. We're actually doing the other one first. Sorry. Okay, do you remember SOHCAHTOA? No. Little bit. I hear excitement. Okay, so SOHCAHTOA is how you evaluate, okay, different trig functions. So, write it at the top. SOHCAHTOA. So, here's what that stands for. Sine, anybody remember? Stands for opposite over hypotenuse. Oh, yeah. Okay, so that's so. So is sine equals opposite over hypotenuse, SOH. Okay, go down to the next one for cosine. Cosine equals, if it's adjacent over hypotenuse. And then TOA, T-O-A, means tangent equals, what do you guess? OA. So what was O? Opposite over A is adjacent. Okay? We're going to skip these for right now, so ignore these. Okay, so what does hypotenuse, opposite, and adjacent stand for? Okay, look at the triangle above it once you write those three down. Okay, triangle above it here. This letter, okay, this is a theta. That is the symbol that is typically used for an angle. So if it's a side, you might use like A or B or X, but usually for an angle, they would put that little symbol. It's called a theta. Now, where the theta is matters for two of the sides, but one of the sides is always the same. Which side is always called the hypotenuse? Okay, the longest one. This is the hypotenuse. Okay, it's always the hypotenuse because it's the longest side in the triangle. Longest side. And it's opposite from the right angle. Or let me say across, not to use opposite. Across from the right angle. Okay, now let's talk about what I mean by across. Okay, across means that if you're a person and you're standing in the corner, okay, I can touch these two walls. Which one can I not touch? That's the hypotenuse. Okay? Now, because my guy needs to be standing at theta, that's going to tell me which one's opposite, which one's adjacent. So, draw your little guy right here. Which two walls can he touch? The hypotenuse wall and the bottom wall. This wall is called the adjacent wall. Do y'all know what adjacent means? Okay, adjacent just means you're touching it. Okay, and then which wall can the guy not reach? He can touch these two. He can't touch this one, so that's the opposite.
So wherever the theta is where like the little side?
Yes. Okay, now this is where it gets tricky. Adjacent is not always on the bottom. Opposite is not always the side. Depending on where your triangle is, okay, and where your theta is going to determine that. So we're going to do a little baby version right here, just to make sure you get it. So this time, I want you to do the same triangle, but I want you to put your theta in the top. So it still needs to be a right triangle, but this time we're going to put the theta in the top corner instead of in the bottom corner. Now, which side is the hypotenuse always? This one, okay? So this is still the hypotenuse. Okay, but if my little dude is right here, which side can he be touching? The hypotenuse and what? The adjacent. That's the adjacent side. Bless you. And then which side is he looking across at that he can't reach? That's the opposite. Make sense? Okay, so now we're going to go to your warm-up. Technically, you should have already learned all this in geometry, but some of us have not remembered a lot of that anyway. So now you're going to this guy, yeah? Okay, so first thing I want you to do is look at your triangle. Am I okay to pull this? Good. Okay, first thing I want you to do is look at your triangle. In order to do SOHCAHTOA, you really need to know all three sides. So looking at that triangle, I only know two sides, right? So let's find the third side. That's step one. So if I know one side is 3 and the other side is 4, I'm going to do Pythagorean theorem, which we practiced yesterday. So I'll do 3 squared plus 4 squared equals, we'll call this c squared. What's 3 squared? 9. 4 squared is 16. 9 plus 16 is 25. And then square root both sides. What's the square root of 25? 5. So this side is 5. Okay, then in order for me to do sine of b, does it have, okay, so b is here. Put your theta in this corner. If I want sine, is that so, ka, or toa? So. Okay, what does the O stand for? Opposite. What does the H stand for? Hypotenuse. So if my little guy is in this corner, okay, which side can he touch? The adjacent is here. The hypotenuse is always the slanty side. And then the opposite side to him that he can't touch is going to be here. So which side is the opposite side? 3 over 5. Okay, now we haven't talked about tangent yet, so I want you to make it cosine. But it's going to be cosine of b. Okay? So we're using the same angle. B is here. What is his, so it's so, this would be ka, right? Which is adjacent over hypotenuse. What's my adjacent side to angle B? 4. What's my hypotenuse? 5. So it'd be 4 over 5. Okay, one more left. We're going to find tan. Tan of B. Okay, tan of B is the TOA part. Tan equals opposite over adjacent. What is my opposite side? Opposite is 3, adjacent is 4. Yeah. So based on which of your trig functions you're using, the SO, the ka, or the TOA, you're going to be using a different combination of the sides of the triangle. That is why you need to know all three. Make sense? Okay, go down to the next one. Okay. Okay, it says tan of B is 7 over 5. So, ka, or TOA? TOA is opposite over adjacent. Okay, then where's angle B? This little guy right here. So let's label the sides first. This is always the hypotenuse. Okay, the longest side. The base is which one? The adjacent or the opposite? Adjacent, because it's touching it. If I draw my little guy, he can touch these two walls. So this is adjacent, which means the other side is opposite. Now, if tangent equals 7 over 5, then what is the opposite side? 7. And what is the adjacent side? 5. Now, once I know two sides, can I find the third side? Okay, using Pythagorean theorem. So I'm going to do 5 squared plus 7 squared equals c squared. where C is the side that I don't have. What is 5 squared? 25 plus 7 squared is 49. Okay, add those guys up. What do we get? 71? 74, right? Okay. And then from there, square root both sides.
Sorry, isn't there another way to do it too?
Using the 30, 60, 90. So here's why you can't use 30, 60, 90. Thank you for bringing that up. Does it say that this is a 30, 60, 90? No. So those special rules where you can do like the x root 2, and the x, 2x, x root 3, you can only do those if they're special 30, 60, 90, or 45, 45, 90. Now, how do we know that this is not a 45, 45, 90? It doesn't have the little marks, but what do the marks mean? That those sides would have had to be the same. Are they the same? Then it's not 45, 45, 90. And did this side come out double this side? Okay, then it can't be a 30, 60, 90 either. So if it is one of the specials, you can pick which one you like better. But if it's not a special, then you'd have to do Pythagorean theorem. Good question. Yes? Yeah. Okay, so this side is square root 74. Now, we would look and see if that can reduce, but 74 can't. So we're just going to leave it. Okay? So next one we want is cosine. Okay, it tells us that cosine of B is going to be 2 over 5. Now, to make this not confusing, I'm going to redraw the triangle. Okay, so same triangle. Put all your crap in the same places. So A is here, B is here, C is here. Okay, and they tell me that cosine B is 2 over 5, so B is here. So that means that this is my adjacent side still, because I'm in the same corner. This is my opposite side still. And this is obviously still my hypotenuse. Okay, so now they're telling me that cosine is 2 over 5. So if cosine is 2 over 5, okay, that's adjacent over hypotenuse. My adjacent has to be the top, which was a 2, right? And then the hypotenuse has to be 5. And then if I know one side is 5 and one side is 2, how do I find the third side? Pythagorean theorem. Okay, so I'm going to pick the letter A again just because, but you can pick whatever you want. So it'd be A squared plus 2 squared equals 5 squared. What is 2 squared? So A squared plus 4 is 25. Take away 4 gives me 21. And then square root both sides. Okay, now think about your perfect squares. Can that divide by 4, which is perfect?
No.
Can it divide by 9?
No.
Can it divide by 16?
No.
Then it's done. You can't fix it. So this side over here would be root 21. Make sense? Okay.
73.
I know 7's not perfect, 3's not perfect. So I could break it down, but it wouldn't break down to something that would reduce. Okay, so back to your notes. Now we got to do the other side. Okay, so SOHCAHTOA you should have already covered in geometry long ago. Okay, but each one of your SOHCA and your TOA have reciprocal identities. Okay, so a reciprocal just means you're going to flip it. So if cosecant is 1 over sine, that means that it's sine flipped. So what is sine? Opposite over hypotenuse. Then what is cosecant? Flip it. Hypotenuse over opposite. Okay, now secant and cosine are reciprocals of each other. So if cosine is adjacent over hypotenuse, then secant is going to be cosine flipped. The technical word for that is reciprocal. Okay, but you're just flipping it. So hypotenuse over adjacent. Okay, and then tan and cotan are partners. So cotan is going to be tangent flipped. So tangent is the OA, opposite over adjacent. Then what is cotangent? Adjacent over opposite. Okay? So, flip over to the back side. Good. Okay, so now you have a triangle. We're going to have to find all 6. Okay, so example number 1, and another thing too, just to point out if you like memorizing strategies, what do you notice about the first 2 letters? This one's an S, who's it paired with? A C. This one's a C, what's it paired with? An S. So don't put the S's together, don't put the C's together, and you'll be fine. Then tan and cotan are partners, and they sound kind of the same. Okay? So, let's go through our SOHCAHTOA and just label it on our thing here. So what does S go with? O over H. What does cosine go with? So ca. And then my last one is my T, so it's opposite over adjacent. Now, this side is just going to be that side but flipped. Okay? So look at your triangle. I have 2 sides. I'm missing the 3rd side, so I'm going to have to do Pythagorean theorem. So these are my legs. I'll do 3 squared plus 6 squared equals C squared. 3 squared is? 6 squared is? Okay, 36 plus 9 is? Equals C squared, square root, square root. Does 45 have a perfect in it? 9 times 5, very good. And then what's the square root of 9? 3. So this side is going to be 3 root 5 up here. Are we good with that? Okay. So let's do sine first. Sine should be opposite over hypotenuse. And then where did they put the theta? Oh, it says for C. So put your little theta right here. That's where your little guy is going to be. Okay, now, the first 2 sides that he can touch, one of them's the hypotenuse, one of them's the adjacent. So my right angle is here. That makes this one the hypotenuse. And that makes the other one that he can touch the adjacent, which would be this one. So 6 is the adjacent side. And the other one has to be opposite. Very good. So let's set up sine. Sine is opposite over hypotenuse. What is opposite the theta? 3. And then my hypotenuse is 3 root 5. What rule is it breaking? You can cancel out the 3's. Okay, so that's a good point. She said I have a 3 top and bottom. What do I leave on top? A 1. But I can't leave the root 5 on the bottom even if it's under a 1. Yes, put a square root 5 on bottom. Also put 1 on top. So what will I have at that point? Let's see. Root 5 on top, root 5 on bottom. So I have a 1 root 5 on top. And then what's root 5 times root 5? Root 25, which is just regular 5. Yep. Okay, now, for cosecant, what am I going to do with that? Flip it. Yeah? And when I flip it, I'm going to flip sine. What's going to happen? 5 over root 5. Okay, so I take my sine answer, I flip it, then I notice my radical's back on the bottom. We're going to have to fix it. So put a root 5 here, put a root 5 here. On top I'm going to have 5 root 5. But on bottom, what's root 5 times root 5? Root 25, which is regular 5. And then what's going to happen with the 5's? Cross out, and I'm just going to get root 5. Now, quick thing I want to point out to you. Okay, we're going to do this from now on, but for this one I didn't think about it till after we did it. when I got 1 over root 5, at that point my radical is on the bottom. Then when I flip it, is that the same as root 5 over 1? So what I'm going to do from now on is, if my square root's on the bottom, I'm just going to write secant first and flip it before I fix it. Okay, I'll show you what I mean. Okay, so look at the next one, cosine. What are we putting on top? Adjacent over hypotenuse. 6 over root 5. 3 root 5. Okay, and then from there, 6 can divide by 3. What does that give me? 2 over root 5. Because 6 divided by 3? Okay, but now from here, look, I'm going to have to fix this. But if my square root is on the bottom, let me flip it first before I fix it. What is this flipped? And I can just write that answer in before I fix it. Because once I fix it, it ends up on the top, and then when I flip it, it'll be back on the bottom. Okay, so now let's fix this. What do I multiply by? Root 5 top and bottom.
So isn't it 2 root 5 to 5?
Uh-huh. So then on the top, I have 2 root 5. Root 5 times root 5 is root 25, which is regular 5. Make sense? Okay, let's do tan. Opposite over adjacent. What's my opposite side? 3 over 6. Now notice, 3 can reduce over 6. What is it? A half. But I got no square roots in my answer, so that means I don't have to fix anything. Now for cotan, what's it going to be? 2 over 1, which is just 2. Make sense? Okay, ready to do one more? Okay, let's find the missing side first. Okay, so I have a 4 and a 6 root 2. Okay, it does not tell me if it's 30, 60, 90. Is this double that? So we know it's not a 30, 60, 90. So let's do Pythagorean theorem. So it'll be 4 squared plus b squared equals 6 root 2 squared. So 4 squared is 16, that's right. Bless you. Plus b squared. Now let's talk about how these work. If you haven't done one of these before, 6 root 2 squared is 6 root 2 times another 6 root 2. So think about, what's 6 times 6? What's root 2 times root 2? Root 4. What's the square root of 4? And what's 2 times 36? 72. Now, your other option, if you had a calculator, is you could type it in to check it, but you have to be able to do it without, because your test is half calculator, half not. Okay, I know. It's cruel. Okay, but you can do it. So, 6 times 6 gave me the 36. Root 2 times root 2 gave me root 4. Then the square root of 4 is 2, and now I can multiply those out to be a 72. Take away 16. 56. And is there a perfect in 56? 13's not divide it and see. 56 divided by 4. 4 times 14. So square root both sides. And it'd be 4 times 14. Then what's the square root of 4? 2. Get us, yeah? Did we subtract wrong? 72 minus 16. That should be right. $36 times 2. Yeah? Okay. So then root 4 is 2. So it's 2 root 14. So the first thing you have to do is find that missing side. Then I'm going to go through and I'm going to label. Okay, so is O over H. Ka is A over H. Toa is O over A. And then remember, these guys are just flipped. What angle are we using as our theta? A. So put your little theta right here. Which one is the hypotenuse? Okay, so here's my right angle. My right angle's touching the legs. So if it's not touching this side is the hypotenuse. So the hypotenuse is the one the right angle's not touching, the little box. Okay, then if I'm in this corner, here's my little guy. Okay, which two sides can he touch? Okay, this is the adjacent. He can always touch the hypotenuse. And then this is the opposite. So let's do our first one. Okay, sine is opposite over hypotenuse. What's the opposite side? 2 root 14 over. What is the hypotenuse? 6 root 2. Now, fun fact that's going to make this one easier. If you have numbers in square roots, you know how you're allowed to multiply them? If they're both inside square roots, you're allowed to divide them. So, 14 and 2 are both in roots. I can divide those guys. What do I get? Root 7. Now, how are the numbers on the outside going to reduce? 2 out of 6 would be 1/3. Now, you don't have to put the 1. You can, but you don't have to. Okay, now, how would I get cosecant? I'd take sine and flip it. So, root 7 over 3 is 3 over root 7. Am I going to need to fix that? Yes. So put a root 7 here, root 7 here. I get a 3 root 7 on the top, but a regular 7 on the bottom. And you should notice the pattern, that whenever you put a second one, the square root just goes away. You get the number from the middle. Okay, do cosine. Set it up. Adjacent over hypotenuse. Okay? Adjacent is 4 over, hypotenuse is 6 root 2. Okay, the 4 over 6 can be fixed, but I'm going to fix the square root first. Now, before I do that, what's secant?
H over 2.
Yeah, just flip it. So 6 root 2 over 4. Okay?
When can you do that? Or can you just...
So the reason that I'm flipping it now is because if the square root is on the bottom, when I flip it, it's not going to be on the bottom. That's why I'm kind of like putting the answer here first before I fix it. Because once I fix it, the square root's on the top, and then if I flip it, it's back on the bottom again. Okay, so root 2 top and bottom. So I have a 4 root 2 on top. Root 2 times root 2 is root 4, which is regular 2. And 12 times regular 2 is, or 6 times regular 2 is 12. Now, I can divide numbers both inside square roots. I can divide numbers both not inside square roots. That means I gotta simplify that. 4 out of 12, what does that reduce to? 1/3. So it'd be root 2 over 3. Technically, it's a 1 root 2 over 3 because it's 1/3, but you don't have to put the 1. Now, this side, can I reduce the numbers outside of the square root? 3 over 2, keep the root 2 on top. Make sense? Okay, next one. Tan theta, opposite over adjacent. Opposite is which side? 2 root 14. What's my adjacent side? 4. No square root on the bottom. Good news, we don't have to fix it. We just have to reduce. What is 2 out of 4 the same as? 1/2. So I have 1 root 14 over 2. Because of the 2 out of 4 going to a half. Okay, then for my cotan, what do I do with that? Flip it. So it'd be 2 over root 14. Do you have to put the 1? No. You can if you want to, but you don't have to. Root 14 goes top and bottom. So I have a 2 root 14 on top and a regular 14 on bottom. Then can anything reduce? The numbers on the outside, 2 and 14, can reduce to what? 1 over 7, root 14 still on top. Make sense? Okay. Alright, go down to the next one. So we have our little triangle here. This looks similar to what we did on the front. Sine S is 1 over 5. Find SR. Okay, so S is here. Put your little corner. That's your theta. Label the 3 sides, adjacent, opposite, hypotenuse. Just put the letter on your paper. So if this is my theta, I'm in this corner. What side is this? Adjacent. What side is this? Hypotenuse. And the bottom is opposite. Good job. Okay, so if they tell me that sine of S is 1 over 5, that means the top is the opposite, the bottom is the hypotenuse. So it's O on top, H on bottom, so opposite is a 1, hypotenuse is a 5. And if I know 2 of the sides, I can find the third side using Pythagorean theorem. So I'd have 1 squared plus 5 squared. Oops, hold on, that's wrong. 1 squared plus b squared equals 5 squared. And remember, the reason why is that this side always has to be your c. Your hypotenuse always has to be c in your equation. Okay, so it'd be 1 plus b squared. What is 5 squared? Minus the 1 across. Okay, so I have b squared equals 24. Then I square root it and look for a perfect. 6 and 4. Which one's perfect, though? I want to put the perfect one first. 4. So b is going to be root 4 times root 6, which is 2 root 6.
How do you know if it's perfect?
You just have to think about that list of perfects. So, and now 24 is small enough that, does it divide by 16? No. Does it divide by 9? No. Then 4 would have been your next one.
12, but either way, you're going to end up doing 4.
Yes, correct. Correct. Okay, so 2 root 6 is going to go here. And that's the side that they asked me to find, SR. That's this side right here. Okay. Now, for fun, instead of doing letter B, pretend it's fun. Okay, I'm going to have you find the tan of S. So same exact triangle. It's like by the time you do all the work, we don't want to do another one. So tan of S, which sides would I pick? Okay, O over A, which would be which 2 sides? Which is 1 over adjacent, which is 2 root 6. Can I leave it like that? No, flip it. Okay, so I'm going to multiply by root 6 on both sides to fix it. So I'll have a 1 root 6 on top, and a 2 times root 6, which is root 36, which is a regular 6. 2 times 6 is 12. Now, let's say, same question, that you wanted to find the cotan of S. What do I do with tangent? Tan and cotan are partners. I just have to flip it. Now, question. Would you rather flip this version or this version?
First, second, down.
I would pick the first one. Here's why. If I flip this, where's my square root going to end up? On the top, which is already fixed. What if I had flipped this one? Square root ends up on the bottom. I'm going to have to fix it all over again. So when you pick your cotan to flip, I would pick this one. 2 root 6 over 1. Technically, do you even have to put the over 1? No. So it'd just be 2 root 6. Make sense? Okay, one more left. We're finding cosecant. Glenn, what was that? Just homework? Oh, okay, I hope you feel better. Okay, same triangle. Cosecant. Whose partner is that? Cosecant goes with sine. They're partners. Now, sine is opposite over hypotenuse. Then what is cosecant? Hypotenuse over opposite. So set up exact same triangle, different sides. This will be the last one that we do. We'll scribble this one out. So cosecant is hypotenuse over opposite. I have my S up here, my R here, my T here, my theta's here. Oh wait, hold on. It says cosecant of what? So they actually did change the letter on us. So now we want our theta to be here. So label your sides. Okay, remember what we said, cosecant is sine flip, so it's opposite over hypotenuse. So my opposite side is going to be here, because I'm not touching it, that's root 15. And then my hypotenuse is going to be here, which is 2. Now, from there, to find the third side, we have to do Pythagorean theorem. So let's do it. I'm going to do it over here in this space, since we're not doing this one. Okay, it'll be root 15 squared plus b squared equals 2 squared. Now, this is going to come out pretty easy for us, because what is root 15 if we square it? Oh, wait, hold on. What did I do wrong? Y'all see it? I put the sides backwards. Where was the root 15 supposed to go? The hypotenuse. Fix it for me. And then the O was supposed to be on the bottom, which would have been a 2 here. Now, here's how I knew that. When I set it up, that came out big. That's supposed to be the longest side. It should be in the C spot, yeah? Okay, so fix it here. This was the H on top. This was the O on bottom. Okay, so from here, we are doing 2 squared plus b squared equals root 15 squared. 2 squared is what? 4 plus b squared. Now, root 15 squared, they're going to cross out and just give me a 15 minus the 4 across. B squared is 11. Now, good news, 11 is prime. It can't divide by anything, right? So it doesn't have a perfect in it. This side is root 11. Okay? Then we're going to find, let's say, sine of t. So sine is which two angles? O over h. What's my O side? Opposite, which is 2. What's my h side? Root 15. Then multiply by root 15 to fix it, top and bottom. And I get 2 root 15 over 15. Now, can 2 and 15 reduce since they're both outside? Okay, no. What would cosecant, the reciprocal of that, be? Would I flip this version or this version? Yeah, flip this one. So I put my root 15 on top, my 2 on bottom. Why would I pick that one? Because when I flip it, the square root ends up on the top if I use that version. It is. So root 15. Oh, you could have done it that way too, I guess. But it comes out the same. Root 15 over O would have been 2. So, but also remember, they're partners. Okay, so we're going to do the homework that goes with this in class on Monday. Okay, so keep it in your notes. You'll have a quiz next week, I think on Tuesday. So don't lose your notes. You get to use them on your quiz. That'll be really helpful, hopefully. Okay?
I'm really sorry.